Welcome to The Explainer. I'm absolutely thrilled you're tuning in. Look, if you're using AI tools like Gemini or NotebookLM for any kind of professional or technical work, you've probably noticed they can whip up some truly incredible infographics. But there's a massive hidden risk lurking just beneath those polished graphics. Today, I'm putting on my consultant hat to walk you through a rigorous zero-trust verification methodology. We're going to learn exactly how to bulletproof your AI-generated deliverables so they stand up to the absolute toughest scrutiny. Let's get into it.
Let me start by asking you a highly critical question. Would you show an unverified AI diagram to an industry expert? Just imagine this scenario. You're sitting right there in a boardroom, confidently handing a gorgeous technical infographic over to a tough subject matter expert client, only for them to point out a glaring, literally impossible error right smack in the middle of your visual. It's a terrifying thought, right? If you want to protect your professional reputation, well, we need a rock-solid system.
So here's our structural roadmap for today. We're going to hit 5 key areas. First, the presentation risk. Second, precision in specs. Third, component control. Fourth, external integration. And finally, number 5, the final fact check.
Okay, let's dive right into section 1, the client presentation risk. See, there's a massive gap in perception here. What the everyday layman sees is a flawless espresso machine or this beautiful vintage electric guitar. Honestly, it looks fantastic at first glance. But an expert? Oh, they instantly spot the absurdities. They look closely and see things like hallucinated microchips jammed inside a wooden guitar where there absolutely shouldn't be any. Or maybe they spot completely nonsensical floating bolts inside an espresso machine. The thing is, if you don't know the topic inside and out yourself, you might just think the graphic is perfect. And that right there is exactly where the danger lies.
So the absolutely crucial point you need to understand is this. The AI image generation model, it doesn't actually fact check. It simply guesses. While the AI's reasoning engine might be totally brilliant, the underlying image model, the part literally drawing the picture, it doesn't inherently understand mechanical engineering or electronics. It's really just playing a guessing game, imagining what might belong inside a machine. It just throws bolts and wires where it thinks they look cool, which leads directly to those dangerous factual errors. Moving right along to section 2, precision, models and specs.
Now, if you use a generic prompt, like say just asking for an electric guitar, you run an incredibly high hallucination risk. You're giving the AI way too much creative freedom. But look at the enterprise approach we have here. If you provide a specific brand, model, and year, something like an Ibanez AZ2204, the result is grounded in actual web-searched accuracy. Behind the scenes, the AI goes out and finds the real technical specs for that exact model, which drastically reduces its need to just guess. It's a real game changer. To put that into perspective, by making that one simple shift using precise brands and models, your rendered diagram becomes approximately 80% better and more accurate right out of the gate. 80%, that's huge. Most of the components are going to be correct simply because you force the AI to look up a real-world object rather than basically inventing a generic one from scratch. Let's transition over to section 3, component-level rendering control. All right, here's the consultant's secret weapon for you. If you just broadly ask for a diagram, the AI is going to try to show absolutely everything, resulting in this giant, confused mess. Instead, we need to explicitly state which exact components to draw. For example, if we're targeting a Gibson Les Paul, we tell the prompt only detail the body, the electronics and pickups, the hardware, the neck, and the fretboard. See what we're doing? We intentionally prevent the AI from overcomplicating the image by giving it strict boundaries. And this brilliantly illustrates the difference. On the one hand, you get a crowded, confused graphic with a million things going on at once. It's a massive risk for errors because the AI is just trying to do way too much. But on the flip side, you get a clean, targeted visual that focuses only on the precise components we actually requested. By applying these strict constraints, you literally transform a messy, unpredictable hallucination into a clean, highly controlled deliverable.
That brings us to section 4, external source integration. We achieve this reality check through a critical concept called source grounding. Basically, this means attaching external reality directly to your AI. By uploading actual PDFs, technical manuals, or specific web links into tools like NotebookLM or Gemini Gems, you feed the reasoning engine the actual, factual documentation.
This step is incredibly powerful. It minimizes factual errors because the AI no longer has to search the open web or guess. It's relying entirely on the hard technical manuals you just handed it. But, and this is a big but, I need to remind you of a severe limitation here. You must always keep this in mind. Grounding perfects the AI's reasoning side for sure, but the image generator, it might still draw completely crazy parts. You can perfect the data going in all you want, but the final visual rendering side of the AI, the part actually drawing the pixels, might still go totally rogue and confuse things. It's an issue on the image generation side, even if your text data is 100% perfect. Which leads us perfectly into Section 5, the final fact check. All right, here is your absolute fail-safe workflow for total control. Step 1, bypass the AI's text generation entirely. Just ask your prompt for clean, empty, hand-drawn style callout boxes. Don't let it write the technical labels at all. Step 2, export that clean graphic out to Figma, Photoshop, or, hey, even Microsoft Paint works. Step 3, manually populate those boxes with 100% true, factual labels yourself. Boom. You retain total control over the narrative and the data. No guessing required. I really want to emphasize this stark warning directly from our source material today. They said, do not hand off an auto-generated infographic to a client because you know you might get into trouble. And they hit the nail on the head. When you're dealing with super detailed, highly specific technical deliverables, you absolutely must fact-check everything. This rigorous methodology isn't just a suggestion. If you're a professional, this is entirely non-negotiable. So I'll leave you to ponder this. Is your AI quality assurance process truly ready for an expert client? The next time you generate a beautiful technical diagram, I really want you to remember that hallucinated microchip inside the acoustic guitar. Implement this zero-trust protocol. Take firm control of your components and ensure your visuals are as perfectly engineered as the products they represent. Thank you so much for joining me on this explainer today. Stay focused and keep learning.